Greetings, gentlemen. Welcome to the Smart Video Lab. Here I am with the Midterm Unit 1 Review sheet that I gave you in class, and we're going to be going over that. If you're just looking for the answers, what I recommend that you do is skip to the end of the video. After I've written all over this document, at the end of the video, I'll scroll through it very slowly so that you can pause as necessary to get the answers if you just want to check your answers. And then you could go back through and listen to how we solved specific questions as needed. But that'd be a good strategy if that's what you want to do. Otherwise, sit back and enjoy the video. So number 1 from the Unit 1 test review says, you're planning to take on a part-time job as a waiter at a local restaurant. During your interview, the boss told you that their best waitress, Jenny, made an average of $71 a night in tips last week. However, when you asked Jenny about this, she said that she made an average of only $50 per night last week. She provides you with a copy of her nightly tip amounts from last week. So we're looking at the table here to the right. You can see on Sunday, she made $50, on Monday, $45, Wednesday, $48, Friday, $125, and Saturday, $87. So our first question that we want to answer is to calculate the mean and the median tip amount. So of course, to calculate the mean, all we have to do is add up all the numbers and divide by the amount of days that she worked. So she worked 1, 2, 3, 4, 5 days. So that's going to be 50 plus 45 plus 48 plus 125 plus 87. All of that, once you add it up, divided by the 5 days that she works. So the mean value that you'll get there will be 355 divided by 5, which is 71. So the mean is $71. Remember, units are important because that tells us the context of the problem. We're talking about money. Now let's look at the median. So the mean is the sum of all the numbers divided by the amount of numbers that there are. The median is the strictly middle value when we line the numbers up from least to greatest. So the smallest amount she made was 45, then 48, then 50, 87, and 125. So to find the middle value, I can just start at each end, crossing off values, and I arrive at the median, which is $50. So now, I'm not going to write the answers to these questions, but it says, which measure of center is Jenny's boss using to describe the average tip? Now, the word average here is kind of ambiguous because Jenny's using one value and her boss is using another. So it's clear that Jenny's boss is using the mean of $71 to describe her tip. He chose this value probably because it's higher. So if you're looking for a job, he wants to communicate to you the best possible information that he can so that it looks like you're going to make a lot of money. And the mean is higher than the median, so it does a better job for what he wants it to do. Now, Jenny, on the other hand, she uses the median of $50 to describe her tip amount. And that's probably because she wants to communicate more accurately what she makes on a regular night. She's kind of, it seems, excluding the weekends where she makes more money. Probably because she wants to make more money. So she's trying to convince you that she really doesn't make enough. Now it says in part D, which value describes the typical amount of tips per night. And if you go into it and look at it, remember IQR is Q3 minus Q1. So I should be writing this down here. IQR is Q3 minus Q1. So in this case, if I scroll back up, Q1 is like the median of the lower half of the data set. So we're looking at the lower half of the data set. Q1 is the median there, so this would be Q1. And then Q3 is the median of the upper half of the data set. So this is Q3. So to find the IQR, we're going to need to do 87 minus 48, which is 39. Now I'm doing this because I want to find outliers. So in this case, an outlier, the upper bound of the outliers would be anything above Q3 plus 1.5 times IQR, which as we can see is going to be 87 plus 1.5 times 39, which is 145.5, I believe. Let me check that value real quick. Yes, and it is. So for something to be an outlier in this case, it'd have to be above 145.5. None of these values are above that because the highest is 125. So there are no outliers actually in this data set. And when there are no outliers, the mean is the best descriptor. So we would choose the mean because there are no outliers. Notice I didn't check for outliers on the low end because there weren't even any suspicious values on the low end, but I was skeptical about whether or not 125 would be an outlier. So now if we use technology to calculate the standard deviation of Jenny's tip amounts and round to the nearest tenth, you're going to use your TI Inspire, and when you compute that, you should get two options, one of which is SX, and in my calculator I got 34.7, and the other of which is sigma x. So one of these is the sample standard deviation, the other is the population standard deviation. And we'll usually use the population standard deviation, which I got from the one variable statistics calculation in the TI Inspire 31.04. It says round to the nearest tenth, so that's about 31.0. Now notice I didn't show you guys how to do this in the calculator because it's not possible for me to do since I don't have any way of showing the calculator screen on this video. So if you have questions about that, just come and see me one day during lunch. Now going on to number 2, we want to label each part of the box plot there. So the easy one down here is the minimum. Up top we've got the maximum. Q1 is the beginning of the box. Q3 is the end of the box, so that's the first quartile and the third quartile. And then the median is the center line of the box. Now notice this bracket here is looking at from Q1 up to Q3. That is, Q3 minus Q1 tells me this whole width of this box, and that's the IQR. So the width of your box in the box plot represents the IQR, the interquartile range of the set of data. Now another interesting thing to think about is it's called quartiles. So when we think of quartiles, we can think of quarters. There are 4 quarters in any NBA game, so each one of those quarters is 1/4 of the game, or 25%. Each part of this box plot contains 25% of the data points. So 25% of the data falls here, 25% falls here, 25% falls here, and 25% falls here. So that means that the IQR represents 50% of the data. So that's just an interesting thing to keep in mind. Let's look at a specific example to think about it. So if I look here at this box plot, which shows the age of campers at summer camp. First of all, I can find out some interesting things from looking at the box plot. One of those is the range. So the range of this data set is 17 is the maximum minus 4 is the minimum, so the range is 13. Now the IQR, again, that's Q3 minus Q1. So in this case, that's 14 minus 8, which is 6. Now, an interesting question that you might be asked, or that you might want to look at, is let's think about true or false question. True or false? 50% of the campers were between age 14 and 17. So that's looking at this part of the box plot. Now ask yourself, is that true or false? That's right, it's false. Because we just looked at the fact that 25% of the data falls in that part of the box plot. Now, we could correct this range so that it would become a true statement. So here's a true statement that we could say. 50% of the campers were between ages 8 and 14, because that represents the IQR, this part of the box plot, which, as we said, is 50% of the data. Now going on to number 3, the histogram below shows the graphs of telephone bills of customers in a certain city. How many customers had bills of at most $60? So I'm looking at around $60 here. At most $60 means everyone less than 60. Sorry, there should be a correction on this one. It should say how many customers had bills of less than $60, because at most $60 means it could include $60, and from the histogram we can't really tell which of this particular bar falls exactly at 60 and which does not. So we have to have a question that asks something like less than 60. So if I'm looking at strictly less than 60, that gives me this bar and this bar and this bar that I want to take into account. So that's 2 plus 12 plus 18, which is 32. But now I have to look at the scale here in hundreds. So 3,200, which is 3,200 customers who have bills of less than $60. Now, if you've been watching the video, I'm going to go ahead and give you the code. So the way this is going to work for the midterm is the code is actually going to be a sentence. There's going to be 4 parts to the sentence. And the first part of the sentence is the word I. So stay tuned to the other videos to get the rest of the sentence so that you can get the 4 extra credit points on the midterm. And again, to get the 4 extra credit points, you'll have to figure out from the other videos what fills in those blanks to complete the sentence. Now, number 4 is a very interesting one. We're looking at a data set which shows us the age and months of first steps for a number of different people. To be specific, that's 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 24 different people and their age and months at the time they took their first steps. Now, when you have a data set this big, it's going to be really hard to compute the 5-number summary by hand like we did when we computed the median earlier in the first problem. We did it by hand, but now when you have this many values, you really want to use the TI Inspire and the one variable statistics package there, like we did in class many times at the beginning of the year. So if you do that, you should find that the minimum is 6, Q1, first quartile is 9, median is 10.75, Q3 is 12.5, and the max is 15. Now the question is, are there any outliers in this set of data? So remember, for outliers, we want to look at the lower bound and the upper bound. So outliers would be anything below Q1 minus 1.5 times IQR, or above Q3 plus 1.5 times IQR. So for this data set, that's going to be 9 minus 1.5. Let's look at the IQR, which is Q3 minus Q1. So 12.5 minus 9, which is 3.5. So anything below 9 minus 1.5 times 3.5, which is 3.75. So I don't see any values that fall below that from this table here. So far so good. No outliers. Now we have to look at the upper bound. We're looking for things above Q3 plus 1.5 times IQR. So that's 12.5 plus 1.5 times 3.5, the IQR. When I do that, I get 17.75. So we look at the table. Is there anything above 17.75? No. So there are no outliers in this data set. And since there are no outliers, that tells us a bit of useful information. So now the question becomes, which set of statistics would best summarize this data? The 5-number summary of the mean and standard deviation. And we would go with mean and standard deviation. And it asks why? Because there are no outliers. If there were outliers, we would want to go with the 5-number summary as the best description of this set of data. So I forgot standard deviation there. Now going on to number 5, this one's a bit tricky. In the graph below, each dot shows the number of sit-ups and the corresponding age for one of 13 people. According to this graph, what is the median number of sit-ups for these 13 people? So the first thing to think about is which variable are we focused on, age or number of sit-ups? It says what is the median number of sit-ups. We're focused on number of sit-ups. We want to look at this axis, the one that's vertical, if we're looking at the page in the correct orientation. So median, remember, is the middle value. So what we have to do is start the same way we would with a set of numbers. Like if I had 3, 5, 9, 11, 20. I cross off one on the low end, one on the high end, one on the low end, one on the high end. So I arrive at the median. So we'll do the same thing here. I cross off the lowest value, the highest value, the next lowest value, the next highest value, next lowest value, next highest value, and so on. Next lowest, next highest, next lowest, next highest, next lowest, next highest. And clearly, this is the middle value relative to the number of sit-ups axis, this vertical axis here, number of sit-ups. And that value looks like it's right at 50 sit-ups. So 50 sit-ups, D, would be my solution. Number 6 brings us back to box plots. It says the number of traffic citations from 2 police stations, RPD West and RPD East, recorded over a 2-week period. Using the box plot below, choose the letter of the best answer. What is the best estimate of the difference in the maximum number of citations given by each department in one day? So first we have to look at the maximum for East. Falls right in between 200 and 220. So that's 210. Now for West, it falls in between 180 and 200, so that's probably about 190. So 210 minus 190, the difference in those maximum number of citations is 20. Now I want to look at part B. It says which statement is true, and option A is RPD West gave the greatest number of citations in one day. You can look up here at the maximum number of citations each department gave, and it's clear that East, the maximum value of 210, is higher. So that statement's not true because it says West is higher. B says RPD West gave the least number of citations in one day. Look at the least number West gave and the least number East gave. That looks like a true statement. Now let's just verify that the others are false. RPD has a greater IQR. RPD West has a greater IQR than RPD East. Remember, the width of the box represents the IQR. So clearly, the IQR of RPD West is smaller than the IQR of RPD East because the box of West is much smaller. So that one's false. And option D, RPD West has a greater median number of citations. Again, clearly, the West median right there is much smaller than the East median right there. So B is the correct answer. Now this last one's real interesting. I really like this problem. Hint, hint, wink, wink. It says Doug has scored the following scores on his first 4 tests in Common Core Math 1. 98, 75, 92, and 85. The midterm is worth 2 test grade. What score does Doug need to get on the midterm so that his test average will be a 90? So there's several ways to do this problem. Guess and check is one. There's a couple ways to look at it, but the easiest way that I can think to do it is algebraically. So we know at the end of the day that means are found, or averages are found, when we take all the values and add them up and divide by the number of values. So he's had 4 tests so far, plus the 2 test grades that the midterm counts for. So that's 6 total tests. And so we've got 98 plus 75 plus 92 plus 85. Now let's say that X represents his midterm grade. We can incorporate that here by saying plus X plus X. So when we add up all these values for all his test grades and divide by 6, we want that to be equal to an average of a 90. That's Doug's goal. So we can simplify this expression by combining like terms in the numerator of the fraction on the left side. So 98 plus 75 plus 92 plus 85 is 350. And x plus x is 2x. So I get 350 plus 2x over 6 equals 90. Now let's say you don't have a calculator for this part. The easiest way to do that is to do 98 plus 75. 8 plus 5 is 13, carry the 1, you'll get 17. Now we add the 92 onto that. 3 and 2 is 5, 7 and 9 is 16. Put the 6, carry the 1, get 265. We'll add on the 85 to that to get 0, carry the 1. 7 plus 8 is 5. 15, we carry the 1, and we get 350. So notice that that works if you had to do it by hand, which you might. So now to solve this equation, the first thing we want to do is we want to multiply by 6 on both sides, so that we get 6 divided by 6 is 1, so that's eliminated. 350 plus 2x equals 90 times 6. Again, if I didn't have a calculator, 0, 6 times 9 is 54. So you'll get 540. Now I want to subtract 350 from both sides, and you get 2x equals 540 minus 350, which is 190. So now I divide by 2 on both sides, and you get x equals 95. So Doug needs to get a 95 on the midterm in order for his test average to become a 90. One other thing I want to mention that I failed to mention in class is when we talked originally about data, we looked at categorical data versus quantitative. So quantitative data, we said, was something that you could measure with a number, anything that you could measure a quantity, a numerical value, whereas categorical was more about characteristics. So an example of categorical data is eye color or t-shirt size, whereas quantitative data was things like height, what we just looked at, test scores, and things that have numerical values associated with them. So when you think of categorical, think of categories. Like eye colors, you could have category blue, brown, etc. T-shirt size, you have categories large, small, medium. Quantitative height, you could have any numerical height. You could be 6.1 feet, 6.5 feet. All those are possibilities. Same thing with test scores. So that's it for the Unit 1 review video. Thanks for watching. Remember that you got the first part of the sentence in this video, which was I. So watch the rest of the videos for the rest of the parts of the sentence so you can get the extra credit on the midterm. As promised, I'm going to scroll back through slowly so that people can just look at the answers. Remember, you'll have to pause as necessary. I need to plug my computer in before it dies. Whew, that was a close one. Alright, thanks again guys. Have a great day or night, whatever the case may be.